And I will request whoever is speaking should keep the video on, and even question answer maybe suppose somebody is answering a question, his video should be on. बाकी लोग off कर सकते हैं. Yeah, beginning में for some time everybody, all the panelists can keep it on. Then after the event also towards the end for some time we can keep it on and take a snapshot.
Okay. Hello everyone. Good morning. This is V.S. Prasad from NCMRWF, Ministry of Earth Sciences, Government of India. I welcome you all for today's session on Curtain Raiser to India International Science Festival 2020 organized by NCMRWF. This is a program to popularize IISF 2020 and to encourage participation of youth of our country in that program. We also use this opportunity to introduce NCMRWF to the younger generation. We have Professor S.K. Dubey, former director, IIT Kharagpur, with us. In our science community, Professor Dubey is very popular as a professor at Center of Atmospheric Sciences, IIT Delhi. Dr. A.K. Mitra, head NCMRWF, joins with me in welcoming Professor Dubey as chief guest to this program. NCMRWF regularly organizing the Curtain Raiser program and pre-event programs to the IISF from last 5 years as an open house by inviting local school and college students and conducting special programs and competitions for them. This time we are organizing this under special circumstances due to COVID-19. Dr. Mitra took a lot of pain in planning today's program and made it web-based. It gives us an opportunity to invite senior faculty members, research scholars, and young students from various universities to this program. We also have many school children with us. I welcome all of them and encourage them to interact with them during the session. I also welcome Dr. Aravind C. Rande, Scientist F. Vigyan Prasad, to join with us in this program. Vigyan Prasad is an autonomous organization of Government of India. It serves India's science popularization agenda. So he is the right person to introduce IISF 2020 to this audience, and I request Aravind to give a fine introduction and how to participate in this program, IISF 2020. I also welcome my colleagues from NCMRWF to participate in today's program and request them to introduce NCMRWF to young participants and also interact them with them actively. With this, I request Dr. Indira Rani, young scientist from NCMRWF, to take program further. Dr. Indira.
Thank you, Dr. Prasad. And good morning all. Once again, I welcome everybody to the 6th International Science Festival, IISF 2020 Curtain Raiser program, organized by National Center for Medium Range Weather Forecasting, Ministry of Earth Sciences. It is mainly for young students, researchers, and our media friends. And our Honorable Minister, Dr. Harshavardhan, Minister of Science and Technology, Minister of Earth Sciences and Health and Family Welfare, inaugurated the Curtain Raiser for the Mega Festival on 17th November 2020 to kickstart different events. This 6th International Science Festival 2020 is being jointly organized by Ministry of Science and Technology, Ministry of Earth Sciences, and Ministry of Health and Family Welfare in association with Vijnana Bharati. The main event will be held during 22nd to 25th December 2020 in a virtual platform this year. And the registration for participation to this event is now open. And this year, the theme of IISF 2020 is Science for Self-Reliant India and Global Welfare. And as many of you know that India International Science Festival is a platform for people from different fields to come together for sharing their scientific and innovative ideas. IISF aims to highlight the importance of science in the nation building and inspiring young talents towards innovative thinking and motivating them in the field of science. So in that background, today NCMRWF welcomes all of you to its IISF Curtain Raiser program through the virtual platform. The purpose of this event is to create awareness among the young minds regarding India International Science Festival 2020 and to highlight the activities of NCMRWF. So NCMRWF is a pioneer institute in the field of weather and climate modeling under the Ministry of Earth Sciences. Our mission is to develop and innovate numerical weather prediction system for India and surrounding regions. Our scientists are going to deliver short presentations on different aspects of NCMRWF activities to enlighten the young minds and to attract them to the field of weather and climate modeling and data assimilation. To take today's program ahead, now I request Dr. Aravind C. Renade, Scientist F, Vigyan Prasad, Department of Science and Technology, to give a brief introduction of India International Science Festival 2020. Over to Dr. Renade.
Thank you. Namaskar, Indira Naniji. Most respected Professor S.K. Dubey, sir, Head of the NCMRWF, Dr. A.K. Mitraji, my known friends and very close associates from NCMRWF, Dr. Suryakanti ji, Dr. A.K. Prasad ji, and Dr. Praveen ji. This is a great occasion for me to be part of this curtain raiser organized by NCMRWF. And I just would like to share the screen through which I can depict certain glimpses about what is going to be there in IISF 2020. Just a second. Yeah. So as Dr. Indira Raniji mentioned, that India International Science Festival is an initiative by 3 different ministries. And of course, every year, one of the organization or an institution under the ministry is supposed to be and co-organizer or a host of the event, along with the Vigyana Bharati, which is the India Science Movement, led by the scientists. And there are about more than 10,000 members that they have, and they are the joint partner in organizing this event. So it is a right time to just talk about the today's event in a very short time. As Indirani ji mentioned, that the theme every year for the IISF becomes part and parcel of the whole event. So this year we say, as she correctly said, Atmanirbhar Bharataya Vishwa Kalyanacha Vigyanam. Exactly the science for the self-reliant India and the global welfare. And as I mentioned, every year, 3 different ministry, in fact, last year, Ministry of Health and Family Welfare has been associated with this event. And now they are also a joint partner for this, along with the other departments under the Science and Technology, Ministry of Science and Technology, as well as Ministry of Earth Sciences. And of course, every year, one of the main objective of this IISF is to promote the scientific temper among the masses and especially the young children. And it is quite obvious to understand to do such kind of thing, there is a necessity of knowing or having a platform through which every partner or every part of the society can get affiliated to this program. And in fact, objective also includes that each and every part of the society should be associated with this. And we are quite successful in doing that, as we could see the progress it has happened. Every year, the events are being increasing. Like to just give a glance at the earlier IISF, it started in the year 2015, organized at Delhi at Indian Institute of Technology. And initially, there were only 8 events in the entire IISF. However, as you see, every year it was increased. In 2016. Again, it was organized in Delhi at National Physical Laboratory, and the event were 9. In 2017, it was organized at 3 different places in Chennai, that is IIT Madras, Anna University, CSIR Labs, and NIOT, which is of course a part of Ministry of Earth Sciences. And you all aware about these institutions in some way or the other. And that year, the events increased to 16. 2018, the events increased to 22, and that was organized at Indira Gandhi Pratishthan, Lucknow. And in 2019, when in which Vigyan Prasad was the coordinating institute, in which the number of events were at 28. And in fact, in Kolkata, there were 5 different venues which were where this IISF was organized. Now, of course, when we come to the 6th edition of IISF, it is very essential to understand and know how many such kind of events are being organized and who are all the people those are going to be associated with this. So certainly, this year's responsibility is with the National Institute of Science, Technology and Development Studies, that is CSIR's NISTAD lab. And of course, the in this pandemic situation, as Prasadji and Indira Raniji has mentioned, this year is a full of challenge, and this year this is not going to be a event which is where the people are going to come on the physical presence, but this everything is going to be on the virtual platform. And in spite of this pandemic situation, one can say that the moral and the enthusiasm of the organizer and the people associated with this has never been less in any of the considering the last experience. And this year the highest number of events are getting organized. There are 13 more events are being added up in this year, and I will just mention about it in a very short. And as I said, in each and every part of the society is getting associated with this event. Like, as we can very easily understand, the viewers that we are now addressing, all school children, the teacher community, researchers, scientific community who are working in the research laboratories, technocrats, technologists, industrialists, innovator, entrepreneurs, and in fact, the people we hardly could think, but they are also part and parcel of this ISF, including the farmers, artisans, craftsmen, and in fact, what we could say, a very common and layman who just would like to know what is the development has happened in the field of science and technology through the exhibition. So exhibitors are also going to be part of this. So now if we look at these 41 events, especially in 2020, these 41 events are being categorized in the 9 different verticals. Number one is about the science for agriculture and rural development, which consists of about 3 activities, which is agricultural scientist meet, then agri-tech, which talks about and demonstrate about the technology developed for the agriculture. Then we have traditional craft and artisans meet and expo. Then we have a second vertical which has a sustainable development, and there are 7 different activities that we could see here. Is a biodiversity, clean air, then we have habitat, then health research conclave, then waste and sanitization and water. And all those red colors that you could see are the newly organized events in year 2020. Then we have a third vertical called the national and international linkages, which has got 5 events under this, which is a global Indian scientist and technocrats meet, which is popularly been known as a GIST. Then we have an international science literature festival known as a Vigyanika, in which you could imagine that every authors, poet, all the creative writers, everybody can participate in this, and there are huge amount of programs are being planned under the Vaigyanika, including the interactions with the popular science writers, and at the same time, the extremely focused areas and the scientific community who will discuss about the various aspects of science and technology. Then we have got the overseas ministers and diplomat conclave. We have science diplomacy, which is the newly added event in this year. Then we have states S&T ministers conclave. By and large, one can say that each and every aspect of the science, including the policymakers, are being taken in consideration, so that they should well aware about the development as well as what is the need of making the science as a part of their life in some way or the other, through the policy making, through making certain kind of one can say the amendments in the present context. Then in fact the new vertical is an history, philosophy of and the science, in which history of Indian science, philosophy of science, and performing art. So one can say this is a real festival in which every aspect of the life is being considered in such kind of a festival. Then there is an inclusive development in which women scientists, entrepreneurs, conclave is being part of it, assistive technology and conclave for the Divyangjan. Then we have a national social organization and institutions meet, which we all aware that every schemes and every program developed by the government need to take to the people through the non-government organizations. A large amount of non-government organizations representative also comes in this program. Then we have a new frontiers under which we have a Now Bharat Nirman, building for the new India, new age technology show, face to face with the new frontiers of science. Then, of course, when we talk about the science for masses, we have Guinness World Record. In fact, since year 2015, Guinness Book of World Record is an event which is associated with IISF, and successfully every year there are certain number of certificates that IISF is able to achieve. And this year also there are about 5 different Guinness Book of World Records are being planned. Then we have got the International Science Film Festival of India. We have Science and Technology Media Conclave, Vigyan Yatra, Wellness Conclave, Cultural Program, then outreach program and satellite communication event. Exactly what we are right now doing comes under this particular activity called as an curtain raiser. And I'm very happy that each and every organization under these ministries are taking it as an no something which is one of the event through which we all are in a position to communicate to the common people what the institution is doing for you and how we are becoming part and parcel of the society in every aspect. Then when we talk about the science for student, perhaps this is the best way that we could see that these are all events for students. If you all are watching, this is something which is we're really waiting for you. All the engineering students can participate in the engineering student model competition. Then there is a special program for the science teachers named under the National Science Teachers Congress. We have Northeast Students Conclave in which largely students from the Northeast get part of it. This year we have added science education in India. As we all know, the kind of a legacy that India has right from the ancient period, how the science was being taught right from that aspect to the what we really look as in science that no should be taught for the future generation. And we are very, very optimistic that new rather the National Education Policy 2020 will certainly focus on certain issues of this, and this science education in India will talk about that. Then we have a student science village in which more than 2,500 children across the country who are from the very, very rural part of the India. Those and especially those children are being recommended and nominated by the honorable member of parliament through the Pradhan Mantri Gram Adarsh Gram Yojana. So all those children get participate into this. Then we have a young scientist conference and industry and medium small industry sector also. You could see there is a industry academia meet, there is a mega science and technology industry expo, the national startup conclave. In fact, this year also we have added games and toys in which the scientific games and the toys which through which the science can be communicated is also been taken into account. Now I will not go into the each and every details of it because time is too short, but in a very short what I could say that all these events are there is a huge amount of people are being part and parcel of this. One activity is associated with one of the institution under this ministry. There are representatives, there are coordinators who look after all this, and they really think about the objective, the execution, every aspect of it. And number of participants this year also on the virtual platform look forward to have a large participation. One can see the number is minimum 500 and goes up to certain thousand number as well. And the number of event with the particular number of days that has been proposed can also be seen in this table, which I really don't feel that I should read it. If you wish, this PPT will be made available to all interested people. I only can wish and expect that each every one of you, whosoever is interested to be part of such event, please come forward. As Dr. Indira Raniji mentioned, the registration has started just 2 days before, and you as early as possible, if you can register and confirm your participation, there is no registration charges. As we all could see that this is a festival and we really want to make this as a festival for everyone, where everyone comes with the smile, and at the when the person will leave this festival, will at least get certain amount of ideas about the science, what the government of India is trying to do for the society, and all the people working in the laboratories who hardly come to know, or common people come to know about what they do in these laboratories. In fact, today's curtain raiser, wherein we all know one of the premier institution. I'm not really sure how many of you as a viewer know about it, but whatever the weather predictions that we all come to know, and largely now many of you will be agree to me saying that now because of the technology, because of the advancement in every aspect, now every weather prediction is almost come to a precise kind of an forecast, and we are able to get that. And no doubt the credit goes to the institutions and the institution builders. Like today we have one of the prestigious person, Professor S.K. Dubey, then the head of the department, head of the NCMR, like Professor A.K. Mitra, and all other colleagues who are part of it, who are going to tell you about what the NCMRWF does for the society altogether. So these are all the events. I really, as I said, don't want to go. But if you look at the target that we are focusing on, is through this kind of a pre-IISF events, through which we call it as a curtain raiser. Some of us we call it an outreach program. So we look forward to have 1.35 lakh people to get associated with this. And as I said, the event is from 22nd to 25th of December. And these are all the Guinness Book of World Records that we are trying to attend for. So children and teachers, I really appeal to all of you. This is for you. Please come forward and register yourself wherever you could feel correct. And these are all the legendaries. These are all the, I would say, the pioneers of science and who are running the country today. And I really don't need to mention who are all these, and we all know about them. But in nutshell, I can say this IISF is actually waiting for all of you to get associated with this. And I really hope that by this, we are going to get a good opportunity. I can only say I'm sorry if I have taken more time, but Dr. Indira Raniji, thank you so much. Thank you, Dubey Saab. Thank you, A.K. Prasad ji. Thank you, A.K. Mitra ji, for giving opportunity to talk about this in a very short. Thank you so much.
Thank you, Dr. Renade, for giving the details of that IAS of 2020. Thank you very much. So now we will move to the next presentation. So as Dr. Prasad already mentioned in his welcome address, today we have Professor Shishir Kumar Dubey with us as the chief guest. So first I will introduce Professor Dubey to the audience. Professor Shishir Kumar Dubey has been, he received his PhD in fluid dynamics from Lucknow University. He is a former scientist in IMD, and he is the former professor of Indian Institute of Delhi, former director of Indian Institute of Kharagpur. He also served as VC Amity University, Rajasthan. He was the president of the 5th session of the Rajasthan Science Congress. And Professor Dubey has contributed immensely in numerical storm surge modeling and 3D ocean modeling, and also coastal marine hazards. He is internationally recognized scientist for his contributions in the field of storm surge predictions, and he has published more than 200 research papers in peer-reviewed journals, and also co-authored a book on storm surges. He is also associated with numerous high-level committee related to science and technology and higher education. Sir, we extend our thanks to you for agreeing to be the chief guest of our IASF 2020 Curtain Raiser program. And on behalf of NCMRWF family, I request Professor S.K. Dubey, our chief guest of the day, for delivering his address to ignite the young minds. Over to Dubey, sir. Thank you. Sir, kindly unmute. Sir, can you please unmute?
Okay.
Yes, sir.
Yes, sir.
Thank you.
Okay, sir.
Okay, now I'm audible.
Yes, yes.
Oh, okay. First of all, I would like to thank National Center for Medium Range Weather Forecasting for inviting me to be the part of the discussion and meeting today. I feel greatly honored. I am thankful especially to Dr. Mitra, Dr. Indarani, Dr. Arvind Ranade, and other distinguished guests who are present today with me, and of course, the students and many other persons, because I am getting already on my cell phone, I am getting some messages that I can see you on the YouTube, and maybe probably they would like to interact. As was told, that it is not only the students, but it is also the entrepreneurs, the industry people, the common man, the other persons who want to know what is happening in the science. They will be probably interacting with me. I will be, at the end, I will be very happy to answer to the questions of the, especially the students, where I come from the academic institute, and in the academic institute, I have been involved in the, especially in the atmospheric science, of course, in other things also, but in the atmospheric science, the meteorology, the forecasting and modeling. So I will be very happy to tell the students about these things, and also what is its scope and how they should, why they should opt it and how they can opt it. Well, ladies and gentlemen, I was looking into the theme of that one, Atmanirbhar Bharataya Vishwa Kalyanaya Cha Vigyanam. Very thoughtfully, this theme has been kept. This is the vision of our Honorable Prime Minister Narendra Modi ji. He has mentioned that he wanted India to be Atmanirbhar. I am surprised. Why not 73 years back this thing was thought? Why nobody have thought over it, why we should be Atmanirbhar? If a country becomes the Atmanirbhar, then only it can be called a developed country. In the last 6 or 7 years, but I have been seeing, I have been traveling, ladies and gentlemen, let me tell you, I have been traveling many countries to discuss the science and in deliberations or giving the lectures and that kind of thing. Maybe I might have visited about 40 to 50 countries in the last 35 or 40 years. And in the recent years, I have seen that जिसको हिंदी में कहते हैं दूसरे लोगों की नजर बदल गई है देखने की. इंडियंस को जिस तरह से देखते थे वो नजर बदल चुकी है, और उसके लिए किसने ये करवाया, ये हमारे माननीय प्रधानमंत्री नरेंद्र मोदी जी के वजह से हुआ. Because when we are saying that we want to use the science for Vishwa Kalyanam, we want to use the science for Atmanirbhar Bharataya, that's very important. I was giving a lecture maybe about 2 or 3 years back. You are aware that the Department of Science and Technology gives the responsibility to some of the institutions to organize the INSPIRE program. And in the INSPIRE program, the students are being inspired about why they should take up the science as their career. I had to give a talk on the storm surge forecasting. The host, while introducing me, he mentioned that I am an expert in storm surge and we have developed a model which can save the lives of the people, especially 300,000 people were killed in 1970 Chittagong cyclone due to storm surge, but very few people were killed in 2007 cyclone which hit in the Bangladesh almost at the same place. So when I mentioned this thing, the host said, why you should not develop a model which can divert the path of the tropical cyclone and kill more persons in some area where we want to kill which the country which is not a friendly country. I was surprised. I said, well, look here, we work for the Vasudhaiva Kutumbakam. हमारा हमेशा यही सोचना रहा है कि global परिवार, we don't believe in the global bazaar, which has been in the recent years getting very popular, the global bazaar. We believe in the global parivar, that is Vasudhaiva Kutumbakam. So if we believe in the Vasudhaiva Kutumbakam, we believe in Vishwa Kalyanaya Vicha Vijnanam. So anyway, तो मैं आपके मंच से माननीय प्रधानमंत्री जी को अत्यंत धन्यवाद देता हूं और आभारी हूं कि उन्होंने ये विजन हम लोगों को दिया, जो विजन हमें बहुत पहले इम्प्लीमेंट करना चाहिए था. Well, ladies and gentlemen, about the IISF 2020, the detail was just now presented. I will not be going into the detail of that one, but the thing is that in this curtain raiser, because I am involved with the NCMRWF, I would like to say that when we say the Vigyan or when we say the science, science is a universal thing. The science will not change what is there in India or what is in Bangladesh or what is in the San Jose. Everywhere the science will exactly be the same. Whether it is Newton's law of gravity or whether it is the atmospheric thermodynamics, it will remain same. But the only thing what changes is the technology. Technology is a location-specific thing. And why I am telling this thing, when the Vigyan Bharati was started, I was very closely associated with Vigyan Bharati, especially with the Delhi chapter. We had detailed discussion with Professor Murli Manohar Joshi ji, who was the Minister of Science and Technology and MHRD at that time, the detailed discussion about that, he said the Swadeshi Vigyan. I said, what Swadeshi Vigyan? What it is? Vigyan is a Vigyan. Then he said, well, Vigyan is a Vigyan, everywhere it is same. But when we use the word Swadeshi Vigyan, this also it takes into account everything, science, technology, engineering, and mathematics, which we are calling now STEM. You must have seen in the brochure. So if all these things are being involved, and by using this science, if we can develop a technology, that technology will be our technology, which right from the beginning, 73 years back, or from even earlier to our independence, the technology, most of the industries in India, they believed in importing the technology rather than developing their own technology. For the name's sake, they appointed some scientists to develop the technology, but hardly anything, that kind of thing was done which can be recognized all over the world. But with this theme now, if we start working, I'm sure very soon we will have the technology which will be called the Indian technology. Today, most of the radars, whether it is the Doppler radars or any other radars and any other equipment required for the meteorology or the atmospheric science, are being imported. We are buying those things through tenders, and we go as per the government requirement, the lowest, whatever is the lowest tender, we go and buy those things. Why we cannot develop that thing? Our Prime Minister have been telling, make in India. We should now do that thing. Our students, young students, please listen to this thing, are entrepreneurs. Why we should not have collaboration? We should collaborate with countries who are developing, are making these radars, and start making in India. So make in India will be satisfied. Similarly, the Atmanirbhar Bharat also Atmanirbhar Bharat, that vision will also be implemented. Another thing I would like to mention it here, that is very important for even the science and the technology both. In India especially, if we look the historical, or well, I will not say historical, well, if we look the Vedas, our other religious books and Granth, the Upanishad, all those things, you will find there is mention of something which be implemented much later, or some other country implemented much later. Maybe probably you are aware that our Vedas are being studied in Germany and even in US in detail, because the Vedas have given some sutras. Just they have given some sutras, they have not gone in detail. Of course, in the Vedant, there is some details of the sutras are given, or maybe in Bhagavatam or even in Mad Bhagavad Gita, some detail is coming. But then the thing is that we always neglected that thing. Whenever we wanted to talk in this independent country, anything about our Vedas have mentioned. Even the India Meteorological Department logo, what it says, Adityat Jayate Vristihi. What ordinary man will understand? सूर्य से वृष्टि होती है. अरे कैसे होती है? Now this just a small sutra. This contains the whole atmospheric thermodynamics. Adityat Jayate Vristi. It involves the evaporation, condensation, precipitation, and all kind of the thermodynamics, pseudo-adiabatic and adiabatic and dry adiabatic, everything is involved in this one. So similarly, sutras are there. So all those sutras are being analyzed and studied in other countries, but when you mention it here, earlier you used to mention it here, you were identified as a particular kind of the sect. For example, when I became the director, I have taken over as the director of IIT Kharagpur in 2002. Immediately after that, I joined, the second day, a senior reporter of the Indian Express came to me and he asked, what is your vision? I almost gave some similar vision. I said, okay, what I would like to do, I would like to integrate our old science or whatever scientific development we have done, that with the modern science. That is integrating with, and then we will see whether we can get something new out of that, which will be our the innovative research. The next day in the Indian Express, on the first page, the news was that very soon IIT Kharagpur will start teaching Mahabharata and Ramayana. And well, I don't want to go in detail that thing because the time is short. Well, I'm probably taking more time. Our former president, late president, used to say that Dr. APJ Abdul Kalam, I am talking about him, he used to say, you must have seen this thing, he used to say that until unless you dream it, you cannot achieve the thing. So you should dream it. So if in our Upanishad or in our Puran or in our Ramayana, there is mention of some Viman, so it means that concept was there. Even if the Viman was not there, Pustak Viman was not there, but then somebody was dreaming. Maharshi Valmiki, I do not know how many years back, maybe 10,000 years back, he has this dream that there is a Pustak Viman kind of thing. So that led to the, if suppose we integrate that our fundamental, the old science to the new science, the modern science, we will probably be able to get our own science also, which I was saying that science is a universal factor. Now coming to the atmospheric and the ocean science area for the scope of the young students. Well, my dear young students, you are here. Let me tell you, the atmospheric science and the ocean science is getting so popular today, but somehow or other, the students are not aware. They still think of going to the engineering and technology branches. I'm not saying engineering and technology branches are not important, they are very important. But the science is more important. When IITs started, the first IIT was IIT Kharagpur. Before that, the engineering was being taught in some of the prestigious institutions. Roorkee University was there. The Tata Institute of this, well, but I'm saying Tata Birla Institute of Science and Technology was there. So both in Pilani and in Ranchi, they were teaching it. But at that time, when the engineering was being taught or the technology was being taught to the students, it was not the science-based engineering. Many of you may not be aware, my dear students, especially for the students I am telling, the first director of the IIT, that is IIT Kharagpur, was a scientist, not a technologist, Sir Gyan Chand Ghosh. Gyan Chand Ghosh was a scientist from Indian Institute of Science, Bangalore, and the request of the then Prime Minister Pandit Jawaharlal Nehru, he has taken over as the director of the first institute. And he brought this idea, when we are teaching the engineering and technology, we should bring in the science and mathematics, because without science and mathematics, engineering and technology becomes a thumb rule. It has no value. So that is why the IIT education was at that time different than any other engineering institutions. Now, of course, everywhere it is being used as a similar kind of the curriculum. Today, if you look into, you will find that out of 24 or 25 IITs, at least 7 to 8 IITs, they have atmospheric science as the subject in their, in some, whether they call it atmospheric science or the meteorology or the earth science, in that kind of the nomenclature, they have programs there. So why they have program? They have program because the IITs know that this area has a scope, and if the students are coming in this discipline, they will be getting the job or they become the entrepreneur. Similarly, Indian Institute of Science and Education Research, they were started in 2004 and 5. I was involved right from the beginning of the setting up of the Indian Institute of Science and the Education Research. The first one was probably set up in Pune and the second one was in Calcutta, which I was the first acting director of the Indian Institute of the Science and Education Research in Kolkata. And what I did, I immediately started, as soon as it started, I said we should have the environmental and atmospheric science as one of the area in this one, not only physics, chemistry, and mathematics. So, well, my dear students, there are many Indian Institute of Science and Education Research which have now meteorology and atmospheric science or ocean science as the subject. Indian Institute of Science Bangalore already had this one from the beginning itself. So, therefore, as far as the scope in the academic is concerned, if the academic institution are starting the program, they know there is scope. So you should also look into when you are deciding to go for the studies, higher studies, then you should decide, compare, think up about the atmospheric science. I tell you another important thing. It is not only the government institutions, there are several private institutions and universities. They have also now started the atmospheric science and meteorology as one of the area in their universities. Amity University, Rajasthan, where I was vice chancellor. Anyway, maybe you can say that you were responsible for this one. They have very strong atmospheric and ocean science department. They call that thing Amity Coast Center for Ocean Atmospheric Science and Technology. The department name is Amity Coast. Amity University in Haryana. They have also the Amity Coast and a similar kind of program at Amity University, Rajasthan is there. There are several other private universities. What is that university name? SRM in Chennai. They have the atmosphere, and several other universities are there. I will not go into the detail. Besides this, there are many private organizations. You may be aware that in the Noida, there is a SkyMet, which is not very old organization, but not also very new organization also, but is doing very well. They have employed many young and of course the old and retired meteorologists also to do their forecasting research and the forecasting, both they do it. And there are many other private organizations and the TV channels want to have the 24 into 7 weather forecasting channels. They require large number of manpower. So there is lot of scope besides, of course, government. And I was coming in the end, the National Center for Medium Range Weather Forecast and India Meteorological Department, they require large number of scientists and trained scientists. And there, of course, the Ministry of Earth Science have several other institutions like Indian Institute of Tropical Meteorology in Pune and INQUIST in Hyderabad, NIOT in Chennai. So they require a lot of manpower in this area. So not only they require the scientists, they require the engineers also, because National Institute of Ocean Technology is there. They about the at the end, before I forget, that's very important. I will like to talk about NCMRWF briefly. आपको NCMRWF will talk later on. Probably they will talk about each area. But National Center for Medium Range Weather Forecast, I consider as one of the premier modeling center of the not only the country but of the world. because this, which started in 1989, at that time I was in IIT Delhi, and IIT Delhi was very closely associated in setting up this center with through DST when it's the what you call the project report was being written. The IIT was closely associated in giving the input to the project report, and this premier modeling in this NCMRWF is being done in the atmospheric modeling is there, ocean modeling is there, data assimilation, ensemble forecast, and this forecast is ultimately is passed on to the India Meteorological Department, so giving it to the nation. Now, ensemble forecast, I would like to say, the ensemble forecast which is being done at, which I understand, which is being done at NCMRWF, has the highest resolution forecast, about which I may be wrong, but maybe probably Dr. Mitta may correct it. It's about 12 kilometers at the global level. This is the highest resolution forecast. Nowhere in the world that kind of the resolution is available. NCMRWF is not only providing the input to the IMD, India Meteorological Department, in operational forecasting, they are also doing the research which is of the international level of research. Their publications are high quality publications with high impact factor. I take the opportunity to congratulate the scientists of the National Center for Medium Range Weather Forecasting for fulfilling the vision of our Honorable Prime Minister. Because our Honorable Prime Minister wants research, innovative research, and NCMRWF is one of the organizations besides some other organization of MOES which is involved in the innovative research. Well, ladies and gentlemen, instead of going further in detail, I might have taken probably the much more time than what was given to me. I would be very happy if there are any questions from anybody who is on the YouTube or listening to me, and they want to know, especially the students and the entrepreneurs. Thank you very much. Jai Hind.
Thank you, sir. Thank you very much for such an very enlightening talk. Actually, for sharing your experience and providing the details of the institutions which offer that courses in atmospheric sciences and meteorology, and also guiding the young generation to take science as the career. Thank you very much, sir. Thank you very much for accepting our invitation and being the chief guest and delivering a very enlightening speech. Thank you, sir. So next we will move to our head NCMRWF, Dr. Ashish K. Mitra will now address the participants. Over to you, sir.
Yeah, good morning all participants. And first of all, let me thank Professor Dubey for such an enlightening talk. And let me tell all the audience here that he was my guide while doing my PhD in IIT Delhi. And there are so many students here. So in the Indian tradition, we have this Guru Parampara. So unless you are getting the blessing of the Guru, and you have to work in close association with all your teachers wherever you are working. And thank you, sir, for such a nice, encouraging talk, particularly for the young people. And so what we have done, we have kept few very short talks because this is a curtain raiser for the upcoming IISF 2020 event. So this is an opportunity also to introduce what is being done at NCMRWF, so that many of the young scientists and engineers can come and get associated with this subject. And there is a good number of institutes nowadays, including IIT, IISC, central universities, and many other private universities, as Professor Dubey said. So we are expecting a lot of young people to come and join and work closely with our center. So in the coming few talks, which are very brief, you will get a glimpse. And I will try to share some very important challenging areas in the assimilation and modeling in the field of weather and climate. And before that, let me uh, thank our Honorable Minister, Dr. Harshavardhan, who is the steering committee in the steering committee of this upcoming IISF 2020, which is going to be organized during 11 to 25th of December. And also thanks to our Secretary of Ministry of Arts Sciences, Dr. Rajivan, who gave us all the encouragement to organize this cotton raiser in all the MOES institutes. So we are one of the first to organize. So you will be participating other cotton raiser by our sister institutes of the MOES. And you have heard from Dr. Ranade about the IISF in detail. So I will not tell about that, except I will just remind that you all should go and register. And one point came to my mind, that in India, we are so close to this participating in festivals. So whether it's a Dasera, Diwali, or film festival, or art festival, or nowadays IPL cricket is a festival. So we have to make this science and technology and engineering as a festival. Generally, these scientists and engineers, we are so good students that we participate in all festivals, but when it comes to our own festival, we shy away. We feel very shy and keep quiet. So we have to maintain that festival temperament and celebrate science and engineering. So whenever there is an opportunity, of course, we organize a lot of workshops and meetings, and we take part, but we have to take it to the masses and public. So that's what is our Prime Minister and current Minister, Dr. Harshavardhan, is doing. That whatever achievement, these achievements are not small. Professor Dubey, he said just now that how much we have achieved in last 20, 30 years in the field of weather forecasting, that even public, they know. And a lot of that contribution comes from the modeling. There are many aspects of weather forecasting, starting from observation to interpretation and forecasting. But the backbone of forecasting is now modeling and data assimilation. And in the context of this Atmanirbhar Bharat, so what Professor Dubey also said, that many things can be done in India now, because we have a huge young mass of scientists and engineers and upcoming students. So we may not have the latest technology, but we have the capability to collaborate and manufacture or do it in India. So let it be hardware, software, and that's what frankly we have been doing in the field of weather forecasting. See, many people criticize that we don't develop our model, but to catch up with the latest models and to be able to talk to them in equal terms and adopt the technology itself is a task. And when you adopt and do that, it becomes your model, your forecasting tools. So there is a huge requirement of young people, young scientist, engineer, who should come and join this subject and contribute in the nation building. So I will show share few slides and which highlights the some of the NCMRWF priorities and in general for the young students. So is the screen visible?
Yes, sir, it is visible.
Okay.
It is, go ahead.
Yeah. So this is a curtain raiser for the upcoming IISF festival. And what's the role of NCMRWF? Because we are supposed to encourage all the young students and scientists to learn about all the aspects of science and technology in India. So I'll try to highlight what's being done at NCMRWF and what is the importance and why we should do that. So as you know, we have a wide range of applications starting from energy, water management, food, etc. So everything, India having a huge population, you cannot neglect any area. So the weather and climate information is very closely related to all these sectors. So any small contribution you do in this field, which will have a huge impact on our population and the economy and the people. And this is an interesting point I gathered because India was under the British rule and India Met Department was mostly British scientists were managing, and that's why IMD is one of the oldest department. And you will be surprised, you see what the so-called head of IMD at that time, Dr. Blanford, wrote. He wrote this message to his scientists and mathematicians in UK. What he wrote, that India holds the key to unraveling the laws of the atmosphere. Study monsoon, progress of meteorology would be assured. So when people sitting in UK, their scientists, engineers, mathematicians are working, this is the message he gave, because our Indian monsoon is such a unique system. It has mountains, plains, ocean, and variety of land surface kind of thing, and the contrast in desert and forest, plateau, mountain. So nowhere in the world you will get such a nice kind of setup. So that's what Blanford sent a message way back in 1875, that
Sir, please unmute, sir.
yeah, are you able to hear now?
Yes, sir.
Yeah,
Okay,
now
okay. So, yeah, sorry, it got automatically muted. Anyway, so what I was telling, that most important thing is the monsoon simulation in the modeling. So still it's being pursued by most of the major center, and it's like a
So again, you
benchmark.
have to share.
Oh, 1 minute, sorry. I don't know what happened. Yeah, is it visible now?
yeah, yeah.
Yeah. Now, if you look at the monsoon, the contrast between winter and summer, you look at the 925 hectopascal, which is close to the surface. This is a unique place in world, that complete reversal of the wind, and it makes the Indian Ocean beneath it more complex. And all this thing happens within a year, the annual cycle. And same thing is, if you look at the temperature gradient, within a year, it changes so much. You see in the November, December, and the bottom one is summer. This rapid kind of change happens only in the monsoon environment. If you see other part of the world, only there is a north-south shift in the equatorial ITCZ. Otherwise, some major change in the wind, temperature, and another thing is the topography. You have the highest topography of the world. So that's why what Blanford had suggested, and even today major centers are doing, trying to connect this monsoon. And if your monsoon simulation is good, then it's like a benchmark for the model. Now, if you look at the upper tropospheric temperature, the contrast between winter and summer, what happens, you see due to convection and monsoon, so much of heating happens there. And if you see the annual cycle of the heating related north-south temperature gradient, again, there is a very remarkable temperature annual cycle you can see, which is very challenging to simulate. Now coming to NCMRWF, So this is, as my previous speaker have told, we are doing the modeling center of the Ministry of Arts Sciences, and we have a host of user. Our main user is IMD, and of course we have many other users. And so it's an operational center, and we develop models and data assimilation systems which have direct impact on the various sectors of India and even international capability we have. Because recently there was a all-women officers team from Indian Navy. They were sailing along the equator. They were circumnavigating the world. And you'll be happy to know that from NCMRWF, the real-time forecast of both ocean and atmosphere were given to this Tarini team. And so my colleagues will show you some of the examples of atmospheric things. So I will show you, because in the center we do a lot of ocean modeling and coupled modeling also. So these are some of the examples of surface currents, what we simulate. So what I'm showing in the this slide is, even if the simulation is good, you see in the equatorial belt, a lot of biases develop very quickly in 7 days. So this is one of the challenging area, that in the equatorial region, because it's a air-sea interaction is there. If your equatorial waves and systems are not captured well, then you will end up in problems. So how to handle this? This is one of the challenging area. But if you look at other fields like salinity, so the top panel is the observation, what we call analysis, and the bottom one is the forecast. You see the models are quite good nowadays. It's able to capture 9 days in advance the vertical structure and the time evolution of the salinity, and this is also temperature. You see remarkable agreement between observation and the simulation. And this is a slide which shows the movement of high saline water from the Arabian Sea to the Bay of Bengal. And the top row is analysis. And this is week 1, week 2 forecast from the coupled model. So you see how nicely the coupled model is capturing. But I am showing a broad index, but if you go to finer scale, it may not be so good. So there are problems where we need to work further. Now, this is the monsoon simulation of the coupled model. So the top left one is the observed rainfall. Now you can see the mean model. So roughly over India, the simulation is good, but there are problems like the equator produces a lot of rain, and it has consequences related to the northward movement of the rainfall. And that's why you have a dry bias in the model, and model rains too much in the Himalayan region. So next, these plots show you the biases. So even if the simulation is quite good, there are biases in the equatorial Indian Ocean and the orographic area. So this is one area working on monsoon forecast in all time scale we have to do. These are some of the example of extended range forecast we produce. This is a challenging area. The agriculture and water sector wants forecast up to 4 weeks in advance. So I picked up some very active cases which were predicted 4 weeks in advance. And this is a dry monsoon condition. You see how nicely the coupled model predicted 4 weeks in advance. And we also do a lot of simulation and real-time prediction of the polar region of Arctic and Antarctic, because you may be knowing our ministry has a center in Goa called Antarctic and Arctic Polar Study Center. So they use actually this forecast for their real-time operation, their ship movement. So a lot of this sea ice forecast is very useful for our community. And coming back to NCMRWF skill, so this plot, what it shows, after we became operational in 1994, continuously the skill of the model is improving, but still we have to go a long way. So where we have reached, you can see, so ECMWF says that in 1 decade, they gain only 1 day skill. So we are moving very slowly. So with the available resources, computer, satellite data, and manpower, but still it's very encouraging that there is good progress. And we'll be happy to know that NCMWF ensemble forecast is in the TIGI portal of ECMWF. So whole world can access this data. In fact, many of the young researcher and students can download this data. And recently the other ensemble system from IMD also is uploaded here. So 2 ensemble prediction system data is available, which is a great achievement for India. And there are still the monsoon simulation in the shorter scale. These are the biases of our two modeling system we have in the ministry. So even if the monsoon rainfall looks good in the shorter scale, we have biases. So there is a lot of research work to be done there to improve the model. And another thing we are doing, that earlier there used to be a single model for a single application like short range, medium range, seasonal, and severe weather. But the new concept world over is moving to a seamless modeling system, that you use the same model from very shorter scale to a longer scale. So my colleagues will talk about that. And the importance of coupled modeling is increasing. So this slide shows the upper ocean heat content. This is related to the cyclone Fani. You can see in the Bay of Bengal coast, there is a patch of high heat content which supports the tropical cyclone. So our coupled model was able to predict this 15 days in advance. So this is one of the reasons the Fani cyclone was sustained. So what I am suggesting from this slide, that there is a requirement of coupled model, and you may be knowing that ECMWF has moved to fully coupled model from 2019. So that is one area we are lagging, but we have already implemented coupled models both at IITM, IMD, and NCMRWF. So we are on the job, but we need a lot of people. So earlier there used to be just one model like atmosphere. So now you have ocean, sea ice, and land surface, and coupler, and all this model has to be initialized with data assimilation system for the ocean, land, and sea ice, and maybe shortly a very coupled data assimilation system. And India is spending a lot of resources, our INCOIS and NIOT, in collecting ocean observations. So those observations also we have to assimilate into the ocean and this coupled system. So these are some of the snapshot of the ocean surface observation. These are the subsurface Argos and XBT observation. So we have the ocean assimilation system in MOES, so this is another challenging area, atmosphere ocean data assimilation. So some of my colleagues will talk about that. And another important thing is the international collaboration. So India as a regional leader in the subject of weather and climate modeling and data assimilation, the NCMRWF also is doubling as the BIMSTEC center. So all the BIMSTEC countries work closely with NCMRWF in the modeling and data assimilation. So we organize workshop and training for the BIMSTEC country. And in fact, without the cooperation of the neighboring country, because we need to validate the model and we need a lot of observation. So we are working very closely with our neighbors. And so this is another area of close collaboration. Then NCMRWF also participates in field campaign. So there are many field campaigns which our ministry organizes. So this is one example of Indo-UK collaboration. So one special aircraft, FAM aircraft from UK came and it participated in the monsoon mission, one project called Encompass, Bubble, and Swami. So you can see our honorable minister who actually took a flight from Lucknow and was observing how this aircraft works, and our secretary also came to that flight. So these are very encouraging for us. And there were other joint programs called Bubble, which the Bay of Bengal is being studied. So now, along with the modeling, we have to go to this observation and field campaign, where these modelers and observers have to work hand in hand to understand the processes. Then only the models can be improved. And I will finish with this last slide. I borrowed it from ECMWF. So on the left-hand side, you can see it's the satellite cloud picture of infrared, and the right hand side is a model simulation from ECMWF. And you can see how nicely the models have attained the skill that all the large scale aspect of the convection throughout in the equatorial region, you can see is being simulated so well. So we have reached a stage where the large scale aspect of the global simulation is of very high standard, but there is a need now to go to much higher resolution. Like ECMWF has gone to 9-kilometer coupled model, and the finer scale sub-mesoscale convective system has to be studied. But this is again a big achievement, the modeling community has achieved. And the next challenging area is we are getting a huge amount of satellite data. So we need a lot of younger people to participate in the usage of satellite data and data assimilation. So with that, I will conclude. So to summarize, India has achieved a lot in last 3 decades in the field of weather, climate modeling, atmosphere, ocean, land data assimilation. We are now at par with other international centers in the field of weather, climate modeling. We are working in close collaboration with top international centers and many national institutes to further develop the modeling capability. And this is a multidisciplinary, challenging science and technology area. So we need a lot of young minds to come and work in this area. We need a lot of dedicated, bright young mind to come and work with us. And you see, this application is having a direct impact in the society, economy, and of strategic issues. So NCMRWF welcomes all young students and researchers to come and work with NCMRWF. So with that, I'll stop here, and my colleagues will briefly present different aspects of modeling and data assimilation. And after these presentations, at the end, we'll have a question and answer session. Thank you very much.
Thank you, Dr. Ashish Mitra, Head NCMRWF, for delivering such a nice talk, introducing all the highlights of NCMRWF work and the challenges in the field of meteorology and oceanography. And he also introduced to the audience what is the position of NCMRWF in the global scenario. So now we will move to the real ignition. Our scientists are going to present the activities of NCMRWF, and during the presentation, audience are encouraged to post their questions in the chat box, and our scientist will answer selected questions during the interaction session with the participants. And moving to the presentations, as we all know, there should be a starting point for everything. And for numerical weather prediction also, we need an accurate initial condition to start the NWP forecast. So this initial condition is commonly known as analysis. For that, we need quality meteorological and oceanographical observations. And our scientist, Dr. Suryakanti Detta, is going to deliver a short presentation on the topic of observations and data assimilation. And data assimilation is a process which generates the initial condition or the analysis. So now over to Dr. Surya.
So, hello everyone. I suppose I am loud and clear and my screen is visible.
Yes.
Okay. So, hi, this is Suryakanti Datta from National Center for Medium Range Weather Forecasting. I will give a brief introduction on the observation and data assimilation that is being used as a part of numerical weather prediction. So when we say about observation, the first thing one should know is about the World Weather Watch. So World Weather Watch, as abbreviated as WWW, was established in 1963. It is one of the core programs of World Meteorological Organizations, which has the primary goal of procurement and dissemination of meteorological and other related environmental information, which is required for providing efficient weather services in all the member countries. World Weather Watch has 3 core components. The first one is the Global Observing System, abbreviated as GOS. The second one being the Global Telecommunication System, that is GTS. And the third part is the Global Data Processing and the Forecasting System. So when we say about the Global Observing System, it is tasked with providing observations of the state of the atmosphere and ocean surface. These observations are being primarily used for preparation of weather analysis, forecasts, advisories, and warnings for severe weather events and for other climate monitoring and environmental activities. Now, Global Observing System has various components, which includes surface observations, upper air observations, marine observations. And when we say marine observations, this includes the instruments which are over the ocean surface and also instruments on board the ship that are over the oceans. Then we have the aircraft-based observations. They are also very important because providing us with the upper air observations. Wherever the upper air observation instruments like the radio sounds are not available, aircraft-based observations are really useful. And now we have a huge amount of data coming from various commercial and other airliners. After that, satellite observations. So at the current position of the numerical weather prediction, if we say, or studying the atmosphere, satellite observations has become a very integral part of the entire meteorology and the weather forecasting system. Satellite observations gives a more of a uniform and data coverage all over the globe, where actually the manual operation of the observations is not possible. After satellite observations, we have the weather radar observations, and then we have some other observation platforms, which includes solar radiation measurements, lightning detection, or tide gauge measurements. So moving on from GOS, the next thing that comes important is the global telecommunication system. So global telecommunication system is actually a system through which globally the data that has been received from the global observing system are being disseminated worldwide among the member countries. And that this is very important because with the global telecommunication system, we are able to receive the data in almost real time to provide the timely forecast. And if there is any issues with the GTS system, it actually affects the forecasting system. So we here in the numerical weather prediction, when we depend upon the observations, and global observations are utmost important to us, not only the observations which are of our own country or region. We need observations which are spread globally. So we have to depend completely on almost, I must say, almost a major portion of the data is being received through the global telecommunication system. And in India, we have the regional telecommunication hub is in New Delhi, which receives the data, and then the data is being sent to all numerical weather modeling centers, and one of them is NCMRWF, which has a direct connections with the regional telecommunication hub at New Delhi. So next from GTS, let me give a brief note on what are the different observations that we see here. So these are just the animations that are showing the locations of the surface data, which is on the top left corner here. And this animation is giving around a 20-minute time window locations. And this is just one typical time window that has been shown here. And the lower right corner, we have the ship data. So when we say ship data, these are actually the measurements that are recorded by the instruments which are on board the ship. So these ships could be commercial ships or the passenger ships, but they actually are very helpful and provide informations on the upper air observations through the radio sounds that are being sent from the ships. Also the surface observations over the ship, because other than the ship, it becomes very difficult to get observations from the vast oceans that is encompassing the earth. So next, we are one of the important one is the upper air observations. So for the numerical weather prediction, upper air observations are also very important. So here the top left portion gives the radio sound measurements that are from the upper air observations, and the lower right corner are the aircraft. As I was mentioning, aircraft measurements are from the instruments which are on board commercial and passenger airliners that and they provide an immense volume of data. And it is really very important because we receive data from the areas or regions where the radio sound do not work, especially over the vast mountainous regions or over the ocean regions. And whenever the aircraft passes from those regions, they keep on collecting observations and disseminating them in almost real time. So after that, this is actually, I'm just giving a summarized version. So next very important part is the satellite observations. So satellite observations can be used in both the direct measurements of the satellite data, or we can derive informations from the satellite measurements. So one of the important parameters that are being derived is the satellite derived wind. So here is one section that is showing the how the global coverage of satellite derived winds within a 20-minute time window. Other than the satellite derived wind, there is another very important high resolution and very less biased observation, that is the radio occultation, which is received from the Global Navigation Satellite System radio occultation, and which is proving to be of immense help in betterment of the analysis and subsequent forecast. So once when we say about the satellite observations, there are actually two different forms of satellites that are being used. One is the polar orbiting satellite, or we can say the near polar orbiting satellite, and the second comes the geostationary or geosynchronous satellite. So these two animations here just show how a polar orbiting satellite passes over the entire globe, and when it keeps on recording informations during their pass and then disseminating or transferring it to the Earth stations, receiving stations on Earth. So these are just two typical examples of a polar orbiting satellite. Next comes the geostationary satellite. So this image that we see here is a full disk image, and I'm very happy to say that this image here is being processed at NCMRWF. This image is from the geostationary satellite Meteosat, and we could very clearly see the cycle. It's a very recent picture for 26th November, and we can very clearly see the Nivar cyclone over through the satellite image. Moving on to the next slide, this is an animation of showing in a 25th November 2020. It is showing the progress of the Nivar cyclone. And this is also processed at NCMRWF. These images from the geostationary satellites actually gives us almost a near real-time picture or near real-time status of the various weather events that keeps on happening, and it helps us deciding and rectifying the forecast that we make. And after the satellite observations, what we are saying is about the Doppler weather radar stations. So these are some of the locations of Doppler weather radar stations in India. And through Doppler weather radar, the data that we collect are very important for severe weather events, which includes thunderstorms, which are one of the very important events that needs accurate forecasting. So once we have covered the observations, which comes under the global observing system, next important part is the global data processing and the forecasting system. So which is in short said known as GDPFS. The main purpose of global data processing and forecasting system is to prepare and disseminate meteorological analysis and forecast products, and in a very cost effective way. As per WMO, in India, we have New Delhi and Pune as the designated GDPFS centers. So in part of GDPFS, the first thing that is important is a numerical weather modeling system. In a modeling system, we have numerical weather model and a data assimilation process, which combine to create a modeling system. A model or a numerical weather model serves as a vehicle which conveys information contained in observations taken from previous time to the present time, and creating a four-dimensional structure which is dynamically consistent with its physics and resolution. More detailed about the various modeling systems and numerical weather models will be provided by my next speaker, Dr. Abhijit Sarkar. I will give just a brief note on data assimilation methods. And as the numerical weather model, assimilation process is being done in a cyclic manner, which actually carries information forward through time continuously and from one model run to the next. So what is data assimilation? As Dr. Indira Rani was mentioning, for making a good, accurate numerical weather prediction and forecast, one of the vital part is the initial conditions that is being used for feeding into a numerical weather model. So this initial condition is being generated through data assimilation. So the purpose of data assimilation is to determine the best estimate of the atmospheric state using observations and the short range forecasts. And these short range forecasts are actually obtained from the numerical weather models that are being used for making the long forecasts. So in other way, we can define data assimilation as a process through which real world observations enter into the numerical weather models forecast cycles. Also, it provides a check and a safeguard against model error growth. And also, as I mentioned, it contributes to the initial conditions for the next model run. There are various data assimilation methods available and being used by different forecasting numerical weather predicting centers. So empirical methods are one of the very old methods that are being used, which includes successive correction method, nudging, physical initialization or latent heat nudging. Then came the constant statistical methods and adaptive statistical methods. Within constant statistical methods, the important ones are the optimal interpolation, 3-dimensional and 4-dimensional variational data assimilation. And within the adaptive statistical methods is the Kalman filter, which has various forms, some of which is the extended Kalman filter and ensemble Kalman filter. In recent developments, I have not mentioned here, but I must say in the recent developments, weather modeling centers are actually using a combination of both constant and adaptive statistical methods, and the data assimilation approach is being termed as the ensemble variational assimilation system. So we have 3D ensemble variational assimilation or 4D ensemble variational assimilation. So with this, I will end my talk for today, and I will happy to answer the questions in the interactive sessions. So thank you.
Thank you, Dr. Surya. So we heard from Dr. Surya about the various kinds of observations and the initial condition, that is the data assimilation that prepares the initial condition. So after the generation of the initial condition, what is the next step? So after generating the initial condition, we have to produce the forecast. For that, what we need to do? We have to recreate the atmosphere through simulation and emulation by solving the atmospheric governing equation in lead time. Dr. Abhijit Sarkar, scientist E, NCMRWF, is going to talk to you about atmospheric modeling. So over to Dr. Abhijit.
Unmute. Am I audible?
Yes, sir.
Oh.
You can make it full screen.
Is it full screen now?
Yes.
Okay, thank you, Rani. I will talk about weather modeling. As we have seen the importance of initial condition and data assimilation from Dr. Surya Kanti. So now I will proceed further. with the discussion on weather modeling.
Yeah, slightly come closer to the computer.
Okay, now it is audible? Is it audible now?
Yes, yes.
Okay. So these numerical weather models are nowadays essential tools for weather forecasting. Now, in these basic laws of physics are that govern the dynamical and physical processes in the atmosphere. So they are expressed in terms of partial differential equations. These partial differential equations are then integrated forward in time from a prescribed initial condition to get the future state of the atmosphere. And this whole process is written in
better.
This whole process is written in the form of computer programs, and these programs are then run within a very powerful computer, and that means you can tell the virtual atmosphere is simulated within a computer, and from there we issue the forecast. Now there are many components of this numerical weather prediction modeling. So these components are initial condition, and then we have to formulate these governing equations, and generally these governing equations all are not exact governing equations, they are approximated, and in some cases they are simplified to satisfy our demands, and also keeping in mind these available resources. And then we will see these governing equations cannot be solved analytically, so we have to adopt these numerical methods, and we have to incorporate many artificial boundaries, and then we have to take care in the physical processes, and finally we will get the model output. So I will briefly discuss all these points, and we will see that how at every stage of this numerical weather prediction modeling the errors or uncertainties are associated. Now, Dr. Surya has told the importance of initial condition, and actually this weather prediction. So when we are going to predict weather for 10 days or 15 days, so the weather prediction is an initial value problem. So the final outcome, it depends very sensitively on the initial conditions. And these two, our attempt is always to make these initial conditions as much accurate as possible. So for that only, as Surya told, that we collect the observations from different sources throughout the world, and we combine those observations with our short model forecast to get this best estimated initial condition or analysis. So though it is the best estimated initial condition, but still these initial condition has some errors or uncertainty, and that error that can be very significant in the very significant in the forecast. And now after preparing this initial condition, we have to formulate the model. So their governing equations include this conservation of momentum, conservation of mass equations, and there are two conservation of mass equation, one equation for conservation of air, and then another equation for conservation of water. And then conservation of energy. So here we use first law of thermodynamics, and then the relationship between PV and T, that is that ideal gas law. Now, all these equations, we will see that these are nonlinear partial differential equations. They cannot be solved analytically. So we have to adopt numerical method. And when we will adopt the numerical method, that means we have to discretize the whole atmosphere into grid boxes. And then the differential equations should be converted into difference equations. So a problem of calculus is converted into the problem of algebra. And there, we will neglect the higher order terms of the Taylor series. So we can see that initial conditions, the uncertainty is associated. The governing equations are simplified, so there is error. And then when we are solving these equations numerically, so we are incorporating a lot of errors. So after following these numerical methods, so then we have to incorporate the boundary conditions. Now, in actual atmosphere, from these different boxes, inside boxes, the information moves from one box to another box. Now, in our actual atmosphere, there is only one boundary, that is the lower boundary of the atmosphere, that is the Earth's surface. Now, all these inhomogeneities that is present on the Earth's surface, that cannot be represented in detail in the model, because model has a finite resolution. Suppose a model has a resolution of 12 kilometer. So within the 12 kilometer resolution, that all the details of this of the surface of the earth, so that we cannot incorporate into the model. So there will be some error. And there is no well-defined top boundary of the atmosphere, but to complete the simulation within a definite time with our limited resources, so we have to incorporate some top boundary. Anyway, top boundary does not create much problem, but if we use limited area model, so then we have to incorporate 4 lateral boundaries. So where we have to prescribe these variables, values of the variables, so that also incorporate a lot of errors. So the errors or uncertainty will be incorporated in this weather modeling through the specification of the boundary conditions also. Next come physical processes. There are the physical processes. In most of the cases, they are small scale processes. So they are subgrid, but these effect of these subgrid processes, they are very significant. Their large scale effect is very significant, and somehow we have to incorporate this large scale effect of these small scale or subgrid scale physical processes within this model. Otherwise, all these rains will not occur, the temperature will not be correctly predicted, so model will not give us realistic forecast. The procedure of expressing this effect of the subgrid process is called parameterization, and we capture these subgrid scale processes by statistically. And these are some example of these subgrid scale physical processes, like scattering by aerosols, incoming solar radiation that is coming, then the solar radiation is reflected back, and then emission from earth surfaces, then cumulus clouds they are forming. So all these processes we have to capture within the model, so by some approximations, and these are the main processes, so that we have to include the effect of these processes, that is radiation transfer, then surface process, then vertical turbulent process, clouds and large scale condensation, then cumulus convection. So all these processes, and a lot of uncertainties are associated with the specification of these physical processes or in the process of parameterization. And finally, what we will get? We will get a model output, and we express the model output in graphical form. Like this left side, we can see that it is the precipitation over India and surrounding region. So this is, and we can see this. This is that spatial distribution of precipitation, and right side it is the location specific forecast. And although we know that at every stage of numerical weather prediction method model, so there is error or uncertainty, and our forecast also will have some uncertainty. But in this presentation of this model output, we are not mentioning anywhere that how much uncertainty is associated with this forecast. So we can see that initial condition has uncertainty. Our model formulation also has uncertainty, that which comes through these dynamical processes, through the specification of physical processes, through model formulation, and that results forecast uncertainty. And again, this Earth atmosphere is chaotic in nature. So that means that forecast it sensitively depend on on the initial condition. So in a chaotic atmosphere, the initial condition grows with time, and then so the growth in that chaotic nature of atmosphere, it gives growth in forecast uncertainty. And most important thing is there that this growth in forecast uncertainty is flow dependent. That growth in forecast uncertainty that depends on the atmospheric condition itself. So then can we forecast the uncertainty in forecast? Because we know that our forecast has some uncertainty. Now, if we can beforehand tell that how much uncertainty is associated with the forecast, so that will help our decision makers or users to handle the forecast. So now question is whether we can forecast the uncertainty of the forecast. Now, ensemble prediction system, it provides a way of quantifying the uncertainty of forecast. In the ensemble prediction system, what we do, in place of running only one model, we run several models from several initial conditions. So all these several models, they are very similar, but they are not identical. And all the initial conditions, So they are also not identical, but they are slightly different from each other. So that from best estimated initial condition, our model runs, so that we call deterministic model, and that forecast we call it is deterministic forecast. And this initial condition uncertainty, so that is that probability density function of this initial condition error, so that is covered by all the initial conditions of these members, other members, and we get so multiple forecasts. And we call these black lines, we call these black forecasts, we call it is that pattern forecasts, and this green, so that we call the control forecast. So the forecast is starting from analysis, and we are getting an uncertain forecast, but this uncertainty is less than this climatology. So in place of one forecast, we are getting multiple forecasts. And from these multiple forecasts, we express this uncertainty in terms of probability. So how many members of these are giving a particular forecast, that will give the probability forecast. What fraction of the members are giving a particular forecast, that will give the probability of forecast. So then the forecast is expressed in terms of probability. Suppose this top left corner, so that this is giving this probabilistic forecast of precipitation. So it is giving that what is the probability that the precipitation will be greater than 15.6 millimeter or 1.5 centimeter. So over this region, we can see the probability of precipitation greater than 1.5 centimeter is more than 75%. On the right side, now this location specific forecast also we are expressing with percentile. So that means this green box, it is giving us the top of the green box, it is giving us the 75 percentile, and this bottom of the green box, it is giving us 25% percentile, and this top end of this vertical blue line, it is giving the maximum, and bottom bar of this blue vertical line, it is giving minimum. So at every point, we can see that how many, what fraction of the members have given the forecast up to what limit. And this left bottom, so this is giving that strike probability of this Nivar cyclone, so starting from 23rd of November. So it gives that at the strike probability means it gives that what is the probability that the cyclone center will pass through 120 kilometer distance from a particular grid point. So this is again we are expressing in terms of probability. Now this is about this numerical weather forecasting. Now when we will go to the longer range, or we will go to the extended range forecast or seasonal forecast, so then other components of these climatic systems also become more important, because as long as we are just going to forecast weather, so then we can take these ocean or sea ice, these are constant in nature. So the variability with time over the ocean and over the sea ice and other components of this climatic system we can ignore. But when we will go for this forecast of this at the longer range, so then we have to consider the variability of other components of this climatic system with time also into the consideration. So these components are, along with atmosphere and land surface, we have to take into consideration that ice sheet, then ocean, then sea ice, all these. And the part of this system that manages all the different resolutions, different grids, and different time steps of all these components, that is called coupler. So through the coupler, it manages the interaction between the atmosphere, land, ice, ocean, and sea. Right now in NCMRWF, we run various models. So among them, so from the finest resolution 330 meter DLD model, which runs only in the winter mainly for the fog forecast, and then we run 1.5 kilometer regional model. It is not operational. It is run on the research mode, and it is over in Indian region only. And then operationally, we run 4 kilometer regional deterministic model. So it gives the forecast up to 3 days. And then we run 12 kilometer resolution global model. So that gives the forecast up to 10 days. And at the same resolution, 12-kilometer resolution, as Professor Dubey told, this is the highest resolution global ensemble prediction system of the world. So that we run for 10 days, and there are 11 members, 11 perturbed members and 1 control member run from 0 UTC, and again 11 perturbed members run from 12 UTC to form 23-member global ensemble prediction system. And we have also a regional ensemble prediction system, also the same resolution 4 kilometer, and it also runs for 3 days. And both these regional deterministic model and the regional ensemble prediction system, they cover the whole Indian domain. And also we run a coupled model of 60-kilometer resolution, and it gives a forecast up to 2 weeks, up to 1 month, and it runs for week. It gives seasonal forecast also. So all these modeling system, it is a seamless modeling system. So they have that same dynamical core, but depending on the model resolutions and requirement, the physics option may change. So that's all from my side, Dr. Indira.
Thank you, Dr. Abhijit Sarkar, for giving a very impressive and informative talk on different modeling activities going on at NCMRWF. So now we have seen that we prepared that different modeling activities at NCMRWF. So after the forecast generation, the verification of these forecast fields are very essential to know about the model performance and to improve it further. So NCMRWF has a dedicated team for forecast verification, particularly for the verification of extreme weather events like heavy rainfall, tropical cyclones, heat and cold wave conditions, etc. So now Dr. Raghavendra Ashrit, Scientist F, NCMRWF, is going to talk to you about the prediction and verification of extreme weather events. Over to Dr. Rikhu. Please unmute, sir.
I think now I can be heard.
Yes, yes.
Yeah, thank you, Dr. Indira. I carry forward with my earlier speakers and briefly touch upon predicting extreme weather and approaches that are adopted at NCMRWF. Briefly touch upon the verification also for some of the extreme weather events. This is the brief outline of my talk. I'll quickly take a walk through all the various products that are available on our website and some of the special products for severe weather and weather events of high impact in nature. And my second this thing will be about what are extreme weather events and how they have to be assessed, and what is the role of impact of climate change and others, how the forecasting of extreme weather is impacted by severe climate change and some of those aspects. And just with 2 examples, I'll just try to show one for the Kerala heavy rainfall event and heat wave conditions. I should demonstrate what is the approaches that are adopted at NCMRWF. So for all the students and young researchers, this is a very common sight. Like a weather chart is what a forecaster first looks at, and that gives a summary of the forecast and predictions that are made. This is just an outline of all the forecasting charts that are available on our FTP site as well as on the website. We have, this is the display of tropical cyclone that recently caused Tamil Nadu coast. Wind flow patterns are first guidance for any forecaster at different levels. These are shown from the model forecast. Apart from that, at different locations also, it will be interesting to see how an advancing weather system is changing the near surface and upper air parameters. So we have thermodynamic diagrams that are shown on the right side, as well as the location specific meteograms, so which show advance of a weather system. So similarly, going ahead, like what Dr. Abhijit Sarkar was mentioning about the ensemble system. So in place of one forecast, we can also have multiples of realizations that we want to see. We can see it in terms of a stamp chart or a probability forecast chart. Similarly, we have probability forecast charts and ensemble meteograms. Quickly moving on, we also have exclusively with focus on the severe weather. We have high resolution 4-kilometer model forecasts that are available, and they allow us to predict the lightning, wind gust, and other such severe weather parameters. Apart from that, we also have forecast charts available for other parts of the world. For example, we have a set of products for covering Africa, Afro-Asia, Southern Oceans, and Antarctica. This was also some of these were discussed by our head NCMRWF. And quickly moving on to the recent cyclonic storm, we have very interactive visualizations available to aid the forecasters, and also forecast products are translated in the form of post-processed products that are shown here in the form of storm following EPS gram and meteograms, and also the rainfall probabilities at a particular location. These are various products that are available, but however, what we have come to see is like as a regular practice, we keep evaluating our forecast models and also provide a comparison with other modeling centers that are in India. And we see that as the left panel shows the anomaly correlation for the recent 30 days, and we like the more or less the forecasts and the forecast skill is more or less comparable among all the models. And this is also seen like not just even with the international centers, we get to see that NCMRWF forecast skill is on par with many of the leading centers in the world, as it is shown here: IISF, UK Met Office, NCEP, Bureau of Meteorology Australia, and all other centers. So this is a routine activity which we do. And moving on to the localized type of this thing, when we see that exclusively focusing on the tropical cyclone season, top left panel shows how our root mean squared error has been decreasing in the recent past. All this is result of the improvements that are made in data assimilation, model physics, model resolution, etc. And similarly, we have also evaluated exclusively the skill in terms of predicting the heavy rains and the extreme rains, that is shown in the bottom panel. And this is shown for mountainous regions of West Coast as well as northeastern India. So CD is one of the metrics which is prescribed by statisticians and WMO also to evaluate rare events and heavy rainfall events. And these metrics that are shown here is exclusively for rainfall exceeding the 80th percentile and 90th percentile of the long-term climatology. So there is an indication that we have all the improvements that have gone have also helped us in improving the prediction of heavy rainfall events. However, there are still a large number of challenges and biases, as that can be seen here. The left panels show the mean error for rainfall forecast over India. The top panel shows for September, and next for the October region. We still see that over large parts of India, the model forecasts tend to overpredict or underpredict. Overprediction, like excessive wetness, is shown in terms of blue, and dryness is shown in terms of wet. So this actually poses a big challenge for the forecaster to make use of the model output. So that's the big challenge. Similarly, on the right side, we see that mean error in the temperature forecast during March, April, May. And we see a large parts of India is having warm bias. So there is models have a tendency to overestimate the warm conditions. And so these are the important challenges that modelers are still faced with. So for application purpose, so we have to have various approaches that I'll shortly quickly discuss and briefly touch upon. And just as we all know, like global warming and climate change are reality, and they are impacting even very localized natures and in very, very many unpredictable ways. And it's also like come to light, and many studies have shown how the synoptic weather in forecasting also is becoming more and more difficult. And as can be seen from recent studies over India also, there is increasing trend in warm conditions. Yeah, increasing trend in heat wave intensity, duration, as well as frequency. This is also documented by several studies. And similarly, in terms of rainfall, we have all witnessed several cases in the recent decades. The most infamous one is the Mumbai deluge of 2005. And next, moving on to, we can still see that's fresh in memory is the Uttarakhand event that caused severe damage and flooding over large parts because of different. So as basically what is that we are dealing with? What is the type of problem that is at hand? So extreme events can be understood and defined in many different ways. The right side graphic clearly indicates uh, just to suggest a climatological anomaly from the normal. It could happen in terms of intensity or a rarity. That is what is described graphically. So whenever there is the extreme nature of weather can happen in terms of shift in the maxima, minima, amplitude, magnitude, or the frequency. Sometimes even the most normal type of or very, very frequently occurring event can still cause a severe impact because of non-climatological conditions also that need not be completely blamed on. So that's how we still have, there are very unexpected and unprepared nature of situations also make it difficult to manage the impacts, and climate change is adding to the problem, and that is very much evident everywhere in the world and also in India. So little bit for focus on how India Met Department defines an extreme rainfall event. We can see the IMD classifications of moderate rainfall, heavy rainfall, and very heavy rainfall. So any rainfall amount excess of 200 millimeters, we can say, is extremely heavy rainfall. For simplicity, we can consider 21 centimeters or more anywhere in India can be termed as extremely heavy rainfall. And generally this amounts to 99.9 percentile. So whenever so it is really, really rainfall categorized like this is far end of the tail, and definitely it has potential to cause huge damage. And what we have been seeing is some of the rainfall events that we see are unprecedented, and they have definitely breached some of these extreme categories. And this for the present context, I am touching upon two events and how NCMRWF we have an approach to isolate and define the extreme events in the forecast. So first I'll touch upon the Kerala case, and next on the heat waves case. So this is what we have. This is not long ago. So this was the spatial map that shows the rainfall that occurred during the month of August. You have huge amounts, excess of 100 centimeters over these locations, and the right side panel shows like so many districts breaching huge rainfall amounts. These are based on the observations, and the forecasts we see here are based on our global model, regional high resolution regional model, as well as the ensemble prediction system, ensemble mean. And it's pretty encouraging, like the three panels compared to the top left observations do indicate that models are able to have a clear signature of estimating the observed heavy rains during the month of August, and specifically averaged totaled during 7 to 17th of August. However, that information could not be like very useful if for the forecaster has to see, and we have to further fine tune to be able to see how well we perform. So just averaged over smaller pockets, we do see that models are able to predict the peaks 3 days in advance. Beyond 3 days, actually there is challenge, and if we further try to fine tune, even with high resolution models, there are challenges, and we clearly see that going to just trying to cover over a district in smaller region, we don't tend to have a very good skill. And this similarly for other regions, Some regions have better predictability. It looks like the success rate is much better here in this particular box compared to the earlier one. So this type of variability is also demonstrated in the forecast. So this is where the forecasters need to employ the ensemble prediction system. And for this particular case, it was found that over 12 members out of the 22 ensembles clearly indicated 12 to 20 centimeters of rainfall for this particular event. So this is for valid for 5th of August. And this is what is encouraging, and how the forecast products can be further tailored and fine-tuned to assist the forecaster to isolate and understand if an event is going to be extreme event. And the two panels we see here are the EPS grams for Wayanad, and forecasts are based on 5th of forecast, based on 5th August, and prediction is made for 9th August. And the red boxes, rectangles, indicate increase of rainfall spell during this period. And the rainfall amounts, some of the members indicate the rainfall amounts to be very, very high. So the right panel is specifically showing for Idukki, where a comparison is made against observations and the ensemble spread, where we can clearly isolate the signal of which is shown in red colored box plots, wherein two specific events are nicely isolated, and the peaking and rainfall amounts are also high in which are comparable with the observations in some of the members. So this is a type of approach that can help for the forecaster. Similarly, using this, probabilities are also constructed to show and see how the events could be isolated over different parts of the event. This is for the case of 16th August. We still see high probability of rainfall exceeding 75th percentile. And further going ahead, for each of these locations, we have also constructed the probabilistic forecast, and clearly we see here, this is for Kozhikode, and day 4 forecast shows a probability not very high. It's just around 5 to 25% of rainfall exceeding 11 centimeters. But how it is generally interpreted is, you don't rule out the possibility of such an event, consistently seen over several such episodes, and the forecaster can have confidence that the event cannot be ruled out. Similarly, this is for Idukki and other stations. I'll quickly move on. Yeah, further, how climatology can be used to further isolate the events. And here we can see that the forecast rainfall amounts, although may not be matching in terms of the observed heavy rains and all, although it could be underestimated, but using the climatology, it is possible to show that the predicted rainfall amounts are exceeding the climatological 90th percentiles. For day 5 forecast for 9th as well as for 16th are shown in the bottom panels, and the dark green shaded region is the indication where the forecast rainfall is exceeding the climatological extremes. So both the 90th as well as the 99th percentile. These are some of the techniques which could be very useful for the forecasters to isolate and catch the signal. Similarly, for heat wave conditions, India Met Department has nicely defined categories of anything more than 40 degrees over the plains, especially over the plains, with a departure of plus 4 degrees, 4.5 to 6 degrees as heat wave, and more than 6.4 degrees as severe heat wave. Just based on actual values also, if it is 45 degrees or more, you call it as heat wave, and more than 47 degrees is clearly a severe heat wave over the plains. They have slightly different categories for hill stations. We'll quickly move on. The basic challenge here would be to understand and isolate even during the observation, just based on the observations, is high quality data. If the observation data and network is poor, so actually we will end up missing out many of such events. So I'll quickly skip some of these slides and just go on to some of the cases that we studied during 2019. and tried to see how ensemble forecasts could be used for making accurate and improved predictions of heat wave conditions. So just focusing on the left side panels, they show the regions of where temperature exceeded over 40 degrees, that is top left panel, and regions where the temperature exceeded 43 degrees. So the forecasts on the top panel show models have a tendency to predict warm everywhere, as I was discussing. And through bias correction procedures, we have been able to show and isolate that the heat wave is likely to occur only over smaller regions. So that type of improved predictions are shown here, as can be seen from the bottom panels. Now the heat wave is predicted. High probability of heat waves, temperatures exceeding 43 degrees is only shown for smaller regions. And these are the types of products that are developed. And further going ahead, here also we are making use of the climatology. And these are some of the events from 2019, March, April, May. And yeah, based on extreme value theory and extensive use of extreme value analysis, it is possible to construct extreme forecast index, which will allow us to translate the predictions in terms of binary like descriptions, like yes or no, yes, it's going to be a severe or a very severe heat wave condition. These are the type of indices that are developed for forecasters to quickly make decisions. These are the useful products. Some of this work is still undergoing, and this top panels as well as comparison with the left hand side clearly indicate improved skill and reliability in terms of prediction. So I'll quickly come to the conclusions. I have just described all the deterministic global and regional systems and the products that we have at NCMRWF, and the ensemble systems, and all the products, how they are used for making predictions, tailor-made predictions for extreme weather conditions. Now, some of the emerging ideas are now switching back to the ideas of earlier yester era, like in use of climatological analogs and things, machine learning, a mix and mash of old and new technology that is being used to this seems to be extremely promising and emerging area. And there are several such examples that have come into the literature, and some of them are also being demonstrated. I would just like to thank all the audience and the organizers for giving me all this opportunity. I conclude here, and I'm open for questions. Thank you.
Thank you, Dr. Ashrit. So now, NCMRWF disseminates its analysis and forecast products to its sister organization and also to other government and public agencies for further use in their operational environment. So routine operational run of all these mandate activities of NCMRWF within the stipulated time requires high power computing facility. Currently, NCMRWF has two supercomputers, Bhaskara and Mihir, and Dr. Praveen Kumar, Scientist G, NCMRWF, will give you a glimpse of high performance computing facility at NCMRWF. Over to Dr. Praveen.
Thank you, Indra. Let me share my screen. Yeah, thank you very much, and good afternoon to everyone. I shall be talking about high performance computing for operational weather and climate. The speakers who have spoken ahead of me, they were all telling about the scientific aspects of weather forecasting. I would rather try to limit myself to HPC, high performance computing. What is the use of HPC? Why do we need HPC? For example, the state of weather and climate forecasting are reaching a level where significant decisions are based on forecasting with large economic consequences. Is possible today and will become increasingly possible in the future. The simulation of atmosphere in order to generate realistic representation of Earth's climate and accurate forecast of future weather and oceanographic conditions continues to be one of the greatest challenge of computer age. At NCMRWF, these are basically the computational drivers about which the speakers ahead of me have spoken. One is the model resolution. As we increase the model, you need more compute power. And if you decrease the resolution by half, if you are trying to forecast at a final resolution, and then the computation is a thumb rule that it increases 8 times. And then the integration length, how long do you want to forecast in time? How long, what is the lead time, and how much time you want to integrate the model? That also contributes to enhanced computing power. And then the third one on the left-hand side of the slide, you will see the ensemble forecasting system about which all the speakers or most of the speakers have spoken, which is the latest paradigm in forecasting wherein you give a probabilistic forecast. And then the complexity of the model, whether you have got an atmosphere model or whether you have got a coupled model, atmosphere ocean coupled model, or whether you have sea ice and you have land surface coupled to it and along with the coupler. So all these things contribute to the computing power, and they all require high performance computer. But then each of these aspects will have a different computing requirement. For example, the coupler might be more or less a serial computing job, but each of them will be highly parallelized job, and the amount of parallelization in each of these modeling system is specific to that modeling system. This is basically a slide which shows the model resolution upgrades which happens whenever there is a major HPC upgrade. And if you see from 1988-91, we were running a model with a resolution of 250 kilometers. And at that time, the computing which was available was 234 megaflops. Actually, the computing power of HPCs, they are expressed in terms of floating point operations per second. And in 2015 to 18, we went from 300, in the year 2018, we went to 2.8 petaflop system from a 350 teraflop system in 2018. That was a more than a 15 times or 9 times jump. And then we started, our resolution of the model became 12 kilometers. See, it is not only the resolution of the deterministic model, but it also amounts to the number of ensemble size also, the number of members in the ensemble forecast. So as and when there was a augmentation of computing power, the model resolution has changed, the number of ensemble sizes has changed. This is basically the acquisition procedure. Actually, there is a dearth of people in this area of high performance computing. And even the acquisition of this high performance computing system is a challenge. So this is basically the acquisition procedure which we have devised. And basically what we do is that we try to evaluate a system based on a base system configuration. Now, let me tell you here, the problem with the kind of application which we deal with is application which we deal is that they do not scale. The scalability of our atmospheric or ocean model is a big issue. And this is where young scientists can come, young researchers can come and contribute. And they may not be basically from an atmospheric science domain. They can be even from a computer science or an engineering domain. The scalability of atmospheric codes or the codes which we run is a very big challenge. I will come to this. I'll come to the peak performance of the system which we have and the amount of performance which we are able to achieve from this system. I'll come to that in detail. And I do not want to go to detail of the acquisition procedure. I just wanted to highlight that scalability of atmospheric or ocean code is an issue and which needs to be addressed. This is the computing system which is codenamed as Bhaskara, which we acquired in the year 2015. And this is a 350 teraflop computer, 350 trillion point operations per second. And this machine is based on the Intel processor, which was a Sandy Bridge processor, which was 2.6 gigahertz. And later in 2018, we upgraded this machine to the Mihir supercomputer, which is a 2.8 petaflop system. It was with the acquisition of this system that we went ahead with a 12-kilometer global ensemble system, about which I think the head NCMRWF also spoke. This 2.8 petaflop system, it has got another system, which is a 4 petaflop system, which is hosted at Indian Institute of Tropical Meteorology at Pune. And that is ranked at this machine here at NCMRWF is ranked at 73, and the one at Pune is ranked at 45 in the top 500 list. Every year, twice in a year, there is a global ranking of a top 500 system. Although these systems are ranked at 73 and 45 respectively, the 2.8 petaflop at 73 and the 4 petaflop at 45. But as far as machines which are dedicated for weather and climate research, they stand at 6 in the world today. So this machine, this Mihir supercomputer, is based on the Broadwell processor of Intel, and there are around 2,320 compute nodes. Here, if we compare the previous generation machine with this machine, the previous generation machine works at 2.6 gigahertz. The processor works at 2.6 gigahertz, but this machine works at 2.1 gigahertz. But although it works at a lower clock speed, the number of cores here available is 18 compared to 8 in the previous generation machine. So what I want to stress here is heat dissipation is a major issue in all the systems. And therefore, the power consumption of these machines are very, very large. This is again one area in which young researchers can work. This is basically to show the data reception at NCMRWF, which the quantity of data which has increased over a period of time. If you see, the quantity of data has increased enormously, and this again, since the amount of input data increases, the amount of number crunching also increases. Now, to sustain this supercomputer, we need a lot of support infrastructure to provide the necessary cooling, the necessary power, the necessary uninterrupted power, and things like that. So it essentially means you are running a factory behind the supercomputer where all the science is done. So the installation of this system, which in the recent parlance is known as data center. This data center itself is the designing of the data center itself is a very big challenge, because today we have tier 1, tier 2, tier 3, and this is a tier 4 data center. In a tier 4 data center, you need basically in all this tiering, the amount of redundancy which is built into the data center matters, and that is the qualifying factor from going from tier 1 or tier 2 to tier 4 data center. Here also there is a lot of engineering principles which are involved, and I do not want to go into the details of those things, but there is a lot of opportunity for young people with engineering background to come into this data center design. Here there's a term known as the power usage efficiency, which is very important in deciding what type of HPC infrastructure one should put in place. And then to complete the ecosystem of the high performance computer, we have an internet connectivity, and this internet connectivity is provided by the National Knowledge Network. This is a pan-India network, which is basically a very high bandwidth, low latency network working at 40 to 100 gigabits per second. And we are also a part of that node. This connectivity is basically connected to international network also, like the Trans-Eurasia Information Network, which is known as the Time 3 network, for connectivity to the outside world. And right now we have a 10 Gbps bandwidth of the NCMRWF. I had shown you in my previous slide that we have two systems with that 2.8 petaflop system at NCMRWF and the 4 petaflop system at IITM Pune. These two systems, they work in a disaster recovery mode, not in the active sense, but in case there is a maintenance issue or there is a problem at NCMRWF, all the workload can be transferred to IITM and it can be run there. So to that extent, that disaster recovery is there. And those two systems, they are connected over this National Knowledge Network on 10 Gbps link. And soon we are going to enhance that bandwidth to 40 Gbps. This is basically a schematic to show how the National Knowledge Network works. And there on the left bottom, you'll see CUG, which is basically a closed user group. And here we have connected almost all our sister organization on the NKN. And so that in the closed user group, when an organization which is geographically located at IITM Pune is connected on a CUG, it becomes an extension of our local area network. So the latency is reduced and the data transfer is fast. And this is basically the schematic of the local area network which we have. The local area network also which we have is very robust in the sense that we have a firewall, a unified threat management system also installed into it, where we have an authorization mechanism wherein we have an RSA based token system wherein the scientists can be there in their respective places and they can hook on to our HPC in the most secure way. So all those infrastructure is in place to enable weather and weather forecasting. This is basically to show what is the industry trend. The industry trend shows that there are larger and larger clusters. As I told you, we have a 2.8 petaflop system in which we have 2,320 nodes, and each node has 2 processors. And you can estimate the number of processors which are there and the number of nodes which are there. So the clusters are becoming larger and larger, and the faster and faster microprocessors are coming with increasing number of cores, but lesser and lesser level of sustained performance on user application. This is one of the most important thing which I wanted to specify. Typical numbers are in the range of 5 to 10% of the peak. What we essentially mean here is that if out of that 2.8 petaflop system, we are able to derive maybe 280 teraflop of compute power. That is the kind of sustained performance on our applications. It is basically, if I try to put an analogy, it is just like the car which you have in which the speedometer shows say 200 kilometers per hour, but you can never drive at that 200 kilometers per hour in any of the roads. That is an idealized condition. And then when you are on the road, you can achieve maybe 60 or 80 kilometers per hour. So that is basically the sustained performance, which what I mean. And the ever increasing cost of ownership, the machines are getting bigger, and so you need more space, more power consumption. Today, NCMRWF, I think we pay around 80 lakh rupees for our power consumption, and we have a 2.25 megawatt connectivity at NCMRWF, which we are going to enhance to 8 megawatt to accommodate our future systems. And no real advance in capability. Ever increasing theoretical peak performance numbers are possible, but percentage of peak is very small, which we can derive. So essentially what we mean that we need a balance system. Okay, we need a balance system in which the memory bandwidth, the interconnect bandwidth, the cache bandwidth, all those things are balanced so that we can derive maximum sustained performance from the available peak computing power. So to address this, we need efforts along all components of simulation-based research. That is about application development, for example, grades, algorithms, porting, optimization for a target architecture. Now, if you optimize for a target architecture, then also there is a problem because most of the models are now community developed. So if you optimize it for your architecture, then you will have a problem about portability of the codes. And then, of course, AI/ML is the latest thing in, because see, AI/ML, as far as numerical weather forecasting is concerned, AI/ML can be a factor right from observation processing to data assimilation to forecasting to even dissemination. So there is a lot of thrust which is being put on AI and ML, but today the number of accelerators which we have in this 2.8 petaflop system or even in that 4 petaflop system is just 1% of the system. But in future, we have plans to at least have 25% of accelerators or GPU nodes which can enable AI and ML computing. And AI/ML is becoming more and more important because of the efforts towards exascale computing. Now, execution rate of simulation, dealing with Amdahl's law. Now, Amdahl's law is basically how serial your job is, how much parallel your job is, what is the amount of seriality which is there in your job. And as a matter of fact, in most of the applications which we run, there is a lot of serial jobs which cannot be parallelized. So that is why I told you that we are able to achieve only 5 to 10% of the peak compute power. That is because of the seriality involved in our applications. And then data management, mass storage, access, post-processing, here is where, again, AI/ML can be of a lot of benefit. And then visualization also. And then infrastructure, where power and cooling is another pain area where a lot of focus needs to be done. I think I have done, and this slide is not for interpretation. It shows that we need a balance system. And if you have more flops and if you have lesser bandwidth, we will end up doing something like this. Thank you very much.
Thank you, Dr. Praveen. And now the interaction with the participants. As we are running short of time. We are limiting the questions. We will try to answer some few questions, and the participants can write their questions to director@ncmrwf.gov.in. We will try to answer all the questions. So there are many questions in the YouTube chat box. I will read out some of the questions. And first question is for Professor Dubey. And how engineering students from IIT and NIT can be motivated to join ocean and atmospheric research? Dubey, sir. Can you please unmute? Can do that.
Okay. Can you? Hello?
Hello.
Yes, sir, audible.
I'm audible. The question was that how the IIT and NIT students can be motivated to take the atmospheric science.
Yes, sir.
Isn't it?
Yes,
So,
sir. From IIT and NIT.
Can I answer it? It will be difficult for me to write, but
Yes,
I can
sir,
speak.
answer.
The answer is that there are many institutions, most of the IITs, they have postgraduate program in the atmospheric and ocean sciences. And in the postgraduate program, already BTech from IITs or BTech from NITs, they have been coming and joining the postgraduate program. In the postgraduate program, we give them the MTech and also the PhD if they are eligible to be registered for PhD.
Thank you, sir. Next question. Is NCMRWF running any PhD program? Dr. Ashish Mitra can answer this one.
Yeah, actually, we have started recently JRF program, but they are recruited through the ministry. So currently we have 3 JRFs. So you look for a MOS advertisement for JRF, and they are placed in various institutes of MOS. So you can choose to come to NCMRWF if you are interested in atmosphere, ocean, coupled modeling, data assimilation. And we have MOUs with many universities like BHU, Andhra University, and we are going to sign with more just to facilitate this process, so that even we have contract scientists, very bright scientists who can do registration for PhD. And of course, this is a good channel so that people can work in project also and also can get their PhDs. So yes, so those who are interested, you look for our MOS advertisement and look for NCMRWF contract scientist post, which are like scientist C post. The scale is very good. And many of, we have currently 25 contract scientists, and many of them have registered for PhD part-time, and we encourage PhD. Thank you.
Thank you.
Rani, I just want to add to Mitra sir's statement that from last year, MOES has started MRFP program. Okay, MOES Research Fellowship Program. So under this program, IITM advertise each year for these junior research fellow. So they are recruited by IITM Pune, and from there they are sent to different centers like NCMRWF. So this year we have given requirement of 8 research fellows. So because of the pandemic, it has not been recruited yet, but I think shortly the advertisement will come. So those who are interested to do research, so they can look into the advertisement given by IITM Pune.
Thank you. So next question. As mentioned in the presentation, NCMRWF is producing 10-day forecast. Did you see the signatures of Nivar cyclone in your 10th day forecast? Maybe Dr. Ashrit can answer this one.
Yeah, that's a very interesting question. In fact, we had very good indication consistently from the day 10 onwards. As early as 18th or 19th of November, we started seeing the signature of this cyclone. And subsequently, the next system in Bay of Bengal, which is evolving, that was also shown 4 or 5 days back. So again, with the lead time of around 7 or 8 days, we could see the signature of these systems.
Thank you, sir. So now other questions we will take offline. So now we thank all of you, and especially Professor Dubey. And he spent a lot of time with us. In fact, he was online with us for the full session during the period of this webinar. And he already blessed us with his presence and encouraging words, though it is through the virtual platform. Thank you so much, sir, for your valuable time. And I also take this opportunity to express our gratitude to all our online attendees, especially young students and our media friends, for actively participating in this webinar. And your presence make this webinar a very lively session. Even though we couldn't get time to answer all the questions, we will answer all the questions in offline. Thanks a lot. Also, please provide us the feedback that will help us to improve further. And I thank all the speakers for their excellent presentation and lively interaction with the participants. And also extend special thanks to Dr. A.K. Mitra, Head NCMRWF, Dr. V.S. Prasad, Dr. John P. George, Dr. Renade, and Arulalan for his support. And there is an NCMRWF team who has been working behind the screen for successful running of this webinar, particularly Mr. Arulalan. So thanks to everybody. And just a reminder to the audience, kindly go to the IISF 2020 webpage and register and participate in the exciting event from 22nd to 25th December 2020. And thank you again to everyone, and stay safe. And now we are going offline. Thank you.
Prasad, final word, maybe you can.
Thank you, Dr. Mitra. And I thank Professor Dubey for sparing this time. And this came very wonderfully, and a lot of young students from Andhra University and other places participated in it. And also there are also a lot of questions also came. As Indira mentioned, we will answer all these questions through email. And with this, thank you.
So I take this opportunity to again thank Professor Dubey, my guide and teacher. So thank you very much, sir, for agreeing in a short notice and coming and joining, and we are encouraged by your words. So thank you very much, sir. And
it was great pleasure, I will say, great pleasure. Yes, and especially seeing my student heading one of the premier institute, I was very happy.
Thank you, sir. Thank you. Yeah. So we'll be getting your guidance continuously. And to the young participant, again, I will say, for doing your projects, etc., particularly the MTech projects, please come to NCMRWF and work in modeling and assimilation. So with this
let the corona be over.
Yeah. No, now, sir, many students are working online. We are guiding them through online.
Yes.
Okay, sir. Thank you very much. So thank you all my colleagues. Thank you, sir.
Thank you.